Welcome to this short presentation of my high-angle wells operation and stockpipe prevention course. Let me introduce myself first. I'm ceesstapel, born and raised in the Netherlands. I am an EAD complex well specialist in engineering, supervision, training and coaching. I've got 35 years industry experience. In 1990, I graduated as BSc in drilling engineering at the Oil and Gas University Noorderhaag in the Netherlands. Then I joined Eastman Teleco as NWD LWD engineer, later on as senior direction driller and also as drilling supervisor at IS projects. But I wanted to do more the complex, difficult wells, so after 20 years I left Baker Hughes and I joined K&M. And since then I've been doing all the more difficult, tough wells, like the 40,000 feet wells on the Island project offshore Abu Dhabi, the EAD wells offshore Sakhalin, deep water wells in Malaysia like 4,000 feet of water, 12.25 horizontal wells, major hole cleaning issues, but sometimes also complex wells for that country, like the first horizontal well in Uganda in the middle of Safari Park, but also again the EAD, MPD, MPC wells in the swamps in Colombia, just to name a few. So all this information and all this info I want to pass on to my students. So what are we trying to avoid? We try to avoid the major train wrecks. I'm pretty sure you heard about these wells where everything went wrong and it turned into one big nightmare. Or perhaps you experienced these wells yourself, and that's what we're trying to avoid. So high-angle wells operation and the stockpipe prevention course. In that course we will teach the students how to clean a high-angle hole while drilling, which procedures and practices should be used for the cleaning up of a well, also what the practices are to make a connection in a high-angle well, how to trip or backream out of the hole safely, and how to respond to tight hole. And if a tight hole is encountered, how to identify if the overpull is due to a cutting pad or is it mechanically related, like a lath, a key sheet, just to name a few. The students will be taught what the influence is of the well angle to the amount of torque and drag experienced. Also, what is the impact of your well design on your casing wear and side forces? What is stick slip and how to reduce or prevent this phenomenon? Sinusoidal and helical buckling will be discussed in depth. And all these topics will prevent your well from turning into a nightmare by minimizing the risk for stockpipe incidents. This training is ideal for engineers, companymen, directional drillers, mud engineers, rig managers, and others in the industry who want to prevent issues and enhance drilling efficiency. The training will be delivered by the use of slides, animation and videos. Industry lessons learned, rules of thumb and case studies will be shown to the students. So now I want to show you a few of the slides you can expect when you attend this course, so at least you know what you're paying for. So the first one is like this. What is different in a high-angle well versus a vertical well? So the first of all is of course the hole cleaning. Cutting behavior is very different. What works at a low angle well doesn't always work at high angles. In a low angle well, hole cleaning is important, but it's relatively easy. In high angle wells, hole cleaning is priority number one, and it's not easy. And the so-called clean hole, that is actually a myth. Regarding torque and drag, in a perfectly vertical well, there is hardly any torque and drag. In directional wells, torque and drag can be significant. And in horizontal or extended reach wells, torque and drag are crucial. Sometimes I'm also going to ask the students some questions. So here you can see an example. You see here the two blocks, one short and big and one tall and skinny, with the same weight, 100 pounds. And then the question is, what can you tell me about the force required to move the two blocks? Is it the same? Is perhaps the big one the skinny one more easy, or perhaps the bigger one more easy, anything like that. Another thing is animations. Here you will see how a BSA is stripped through the cuttings, and you can see the cuttings flowing around your BSA through the junk slots. Of course, really important, the buckling. Because if you run casing, liner, completion, or just running in the hole with your drill string, in these high angle wells, EAD wells, buckling is a major issue. So here you can see where the buckling can occur, and this only goes for sliding. So it can happen in the vertical section on the top, your upper tangent or your lower tangent, and even near the heel in long horizontal wells. Buckling, of course, is really important, because if you cannot run your completion in the hole, what's the point in drilling it all? Another issue, of course, are your cuttings. Like here, the shakers are close to capacity with large quantities of the materials shown in the picture below. What does this indicate? First of all, that hole cleaning appears to be effective, or do you think the downhole shocks and vibrations, are they too high? Or perhaps the wellbore is unstable. Perhaps the mud weight is too low, you should increase the mud weight. Or the mud system is not inhibitive. And here are just a few points that students have to choose from. Another question is here, another thing that we discuss is your classic train wreck. Because most of the train wrecks on extended reach wells, they occur on the trips. And the two common themes are those that have bad hole cleaning while drilling, and those that have good hole cleaning while drilling, with poor tripping practices. And the last one, that starts to become a common one in the industry nowadays, because most of your wells are drilled with RNS, so normally you already have high RPMs, high flow rates, so that's all okay, you follow the correct procedures and the practices. But as soon as you start tripping, everything is forgotten, and we suddenly go back to the old vertical well mentality, and that's when all the train wrecks start to come. You have your pack offs, you can have your losses, you name cavings, suddenly appearing before never. All kinds of things can happen on your trips. Here, another one. This is a trip scenario where the string is suddenly stuck after a connection, not during tripping. And suddenly we have major problems, but we still have flow. So what do you think is the best immediate action to take in a connection, in a situation like this? Another one is here, back reaming. Sometimes back reaming is necessary when you have a tight hole on the trips, after verifying that the obstruction was not a cutting bed, or scrubbing if you can't trip conventionally. But don't worry, I know a lot of people are scared of back reaming because of all the issues that can happen. But I will teach you all the correct procedures and practices of how to back ream safely out of a high angle well. So, thank you for your attention, and if you have any questions, you can always email me. Thanks.